Look up at the night sky this November and December, and you might feel something strange. The moon looks impossibly big, brighter, closer, almost alive. But it's not your imagination. These are the final two supermoons of 2025, and they're unlike any we've seen in over a decade. They're pulling the oceans, stretching the Earth's crust, and lighting up cities from coast to coast. But behind this beauty lies something far deeper, a cosmic rhythm that may be slowing down. Before we dive in, make sure to hit like and subscribe to Deep Space Explained, where every light in the sky hides a story waiting to be told. Because tonight, the moon isn't just shining, it's speaking. And we're about to decode its message. The term supermoon sounds like something straight out of a comic book, but it's pure astronomy. It happens when the moon reaches its perigee, the closest point to Earth in its orbit, and happens to be full at the same time. That makes it appear up to 14% larger and 30% brighter than a regular full moon. But here's the twist. Not every full moon near perigee qualifies. The November and December 2025 events are true perigee alignments, meaning the moon will be at its absolute closest distance during the exact moment of fullness. This perfect alignment only happens once every 10 to 12 years, and this time, it's visible across the entire United States, from New York's skyline to the deserts of Arizona. But that's just the start. These supermoons will actually influence Earth itself in ways you can feel and measure. During a supermoon, the moon's gravity pulls harder on Earth's oceans, creating what scientists call perigean spring tides. In November and December, these tides will coincide with seasonal surges, especially along the Atlantic and Gulf coasts, where oceanographers are watching for unusual wave patterns and minor flooding. But it doesn't stop at the waterline. The solid Earth also flexes slightly, and even our atmosphere shifts under the moon's enhanced pull. NASA data has shown subtle increases in atmospheric pressure, as if the air itself breathes with the lunar cycle. And here's where it gets fascinating. As the moon's orbit gradually changes, these gravitational interactions could be revealing that Earth's rotation is very slowly changing too. Are these supermoons a preview of how our planet's balance might evolve in the far future? Long before telescopes or space probes, ancient cultures looked up at the same giant moons and built entire calendars around them. The Maya, the Chinese, and the Anasazi of North America all recognized that certain full moons appeared unusually bright, and they used those cycles to track seasons, harvests, and even predict floods. For Native American tribes, the November full moon became known as the beaver moon, marking the time to set winter traps before the rivers froze. The December full moon, the cold moon, represented endurance, reflection, and renewal, the last light before winter's deep night. To these civilizations, supermoons were omens, signals of balance, endings, and beginnings. And yet, modern science is now revealing something they could never have imagined, that the moon itself is slowly leaving us behind. Every year, the moon drifts about 3.8 centimeters farther from Earth. It's a tiny distance, but over millions of years, it adds up. As the moon moves away, its gravitational grip weakens, meaning supermoons will become rarer and less dramatic. One day, hundreds of millions of years from now, there will be no more total solar eclipses, because the moon will appear too small to cover the sun. This slow cosmic drift tells a haunting truth. These breathtaking supermoons are part of a dying era, a reminder that even the heavens evolve and fade. But before that distant future arrives, something else is happening, a phenomenon so subtle that even NASA's instruments barely catch it. Most people think the moon is completely dead, airless, silent, unchanging. But during supermoons, scientists have detected a faint lunar exosphere, a ghost-like atmosphere made of charged particles and dust kicked up by solar radiation. When the moon swings closest to Earth, solar wind interactions intensify, creating shimmering lunar halos, faint glows sometimes captured in long-exposure photography. NASA's LADEE mission and the upcoming Artemis Gateway are studying these subtle events. Some models even suggest that supermoons trigger mini dust storms across the lunar surface as electrostatic charges lift grains skyward. For a few hours, the moon becomes alive, breathing, glowing, interacting with space in a rhythm older than humanity itself. If you want to witness it, mark your calendar. The Beaver Moon rises on November 15th and the Cold Moon on December 14th, both visible across the continental United States. The best viewing time? Just after moonrise, when it hovers near the horizon, magnified by Earth's atmosphere, glowing gold and crimson. No telescope? No problem. Even with your eyes, you'll feel the difference. Share your photos with hashtag Supermoon2025 and hashtag DeepSpaceExplained, and you might be featured in our next Cosmic Showcase. But as you look up, remember this. The light that touches your skin is ancient sunlight, reflected by an ancient companion, slowly drifting away. So tonight, when you see the supermoon rise, know that you're not just watching an astronomical event. You're witnessing a cosmic relationship in motion. Every bright moon tells a story of oceans pulled, civilizations inspired, and futures unfolding across billions of years. These supermoons remind us how delicate and interconnected the Earth-Moon system truly is. If this journey through time and space moved you, give this video a like, share where you're watching from in the comments, and subscribe to Deep Space Explained, because the universe still has so many secrets waiting to be uncovered. Until next time, keep your eyes on the cosmos.